All right, we're going to look at radians, arcs, and sectors in this section, which, by the way, is 11.7 in your book. All right, so just some definitions first. This portion right here, this curved arc, all right, we call this the arc length, okay? So we can actually measure it, all right, and its length is called the arc length, all right? And we typically use a lowercase l to represent that. This shape inside here looks like a slice of pizza. We call that a sector, okay? And at the center is an angle that we call theta. Theta is a central angle. And we have lowercase r to represent the radius. Now, if we have a situation where this radius distance is draped across this arc, suppose this were equal to r, okay, on the outside. Well, then our theta would equal what we call 1 radian, okay? So 1 radian is a special case where the radius equals that arc length, okay? So what is a radian? What is exactly 1 radian? It is an angle measure that is formed when you have a situation where the radius in a circle is equal to the arc length, okay? It's kind of like an equilateral triangle. Think of it as like an equilateral sector, okay? All three sides, all three parts of its exterior are equal. That's known as 1 radian. All right. So what about 2 radians? What would that look like in a picture? Okay, if our theta is equal to 2 radians, oops, if our theta is equal to 2 radians, by the way, RAD is our abbreviation for radian. Well, we know that 1 radian would be that, approximately. 2 radians would be that doubled. So here's my theta, all right, R and R. So on the outside here, I would have 2 R's. So my theta would be 2 radians, okay? Okay, so what about a situation where now our angle goes straight across, so our theta is really 180 degrees. Here's my radii, okay? Well, if we were to just think about how many radians we would have in here, there's 1, let's say. There's, let's say, 2. 3 would look like that, and then there's this little sliver left over. Well, here, turns out you would need about 3.14 radii to drape it all the way across here. Well, that's pi, okay? So what that really tells us is that, in this case, our theta would be pi radians, okay? So about 3.14, all right? And we know that from that, 180 degrees, right, that's this straight line here, that's really our theta. 180 degrees is the same as pi radians. Now we're going to use this fact a lot more later on in this video when we look at some conversions between degrees and radians and we go back and forth. But for now, I just want to talk about a few quick formulas that deal with sectors in a circle. All right, so here are some formulas to be aware of. All right, so L, which we said earlier, is our arc length. That can be found by doing theta times your radius, okay? That formula, by the way, is given to you in your formula packet. Here's another formula that is given to you. The area of this sector, right? I'm referring to this so-called slice of pizza, okay? Well, area of a circle is pi r squared, and this theta is really just a fraction of that full circle's area. So from that, it's not too difficult to derive this formula, 1/2 theta r squared, okay? That's how we're going to find the area of a sector. So these two are given to you, all right, in your formula packet, so make note of that. Sometimes you might be asked to find the perimeter. This is not given to you, but it's also not difficult to find. If you're going to find the perimeter of this sector, it's just a matter of adding up all of your exterior edges. So you'd have an R plus an R plus an L, so 2R plus L. Let's look at an example. Okay, so here's an example where we have a sector and we know that the angle on the inside is 2.5, and let's suppose that says radians. We know we have a radius of 4. And before we look at a few questions here, understand that a lot of word problems will use language like this arc right here that we're talking about. They say things like it subtends the angle. All that means is if you were to just form an angle here, it's going to intersect with this arc. Okay, it's kind of like the word extend. All right, very similar. All right, why they use that word, I don't know. It's just one of those weird words that are used. Okay, so when an arc subtends an angle, it just means it's forming the angle if you were to extend it out. Anyhow, if we wanted to find our arc length L, okay, in a question, we know it's theta times r, so it's really easy. It would just be 2.5 times 4, so that would give us 10, whatever the unit is, okay? If we had to find the area of that sector, okay, it would simply be 1/2 the theta, which is 2.5 times the radius of 4 squared. If you clean that up, you're going to end up getting 20, all right, square units. If you had to find your perimeter of this sector, this is just going to be the 4 plus the 4 plus the arc length of 10, so 18. All right? All right. All right, finally, let's take a look at some degree and radian conversions. I said earlier that 180 degrees is the same as pi radians. Well, from this, 1 degree would really be pi divided by 180 radians, right? And from this, we get our formula. If you want to convert from degrees to radians, what you're going to do is you're going to multiply by pi over 180, right? If you have 44 degrees, you would just multiply by pi over 180, okay? So it's just in ratio with what you see here, okay? 1 degree is equal to pi over 180. Likewise, if you are converting from radians to degrees, you're just going to multiply by the reciprocal, which would be 180 over pi, okay? But to be honest, it's rare that you're going to have to use either one of these formulas. Most of the time we're dealing with very friendly angles. So there's some, actually there's many that you should have committed to memory. So pi radians is equal to 180 degrees. That's certainly one of them. And that really is the building block for all of them. So you should know that 360 degrees is the same as 2 pi. Now I'm going to start leaving off the RAD, but understand that I'm talking about radians, okay? So 360 is the same as 2 pi. You should know that 90 is the same as pi over 2. Again, we're talking about radians. Another popular one, which shows up with our graphs, 270 degrees is 3 pi over 2. Now, we mentioned before, we talked about special right triangles, okay? So these are important for graphing, okay? But we know we have 30, 60, and then 45, 45 special right triangles. So 30, you need to know, is pi over 6. And guys, just remember, pi is 180. So if you do 180 divided by 6, boom, there's your 30. All right, 60 is equal to pi over 3. Just think of it as 180 divided by 3. And likewise, 45, that is pi over 4. All right, so you certainly want to commit these 3 to memory. All right, and then we have our multiples of our 30, 60, and 45 angles. So, you know, things like 150 degrees. Yeah, you can run it through this formula where you multiply it by pi over 180, and then you got to reduce, okay? But it's much easier to just know, to just recognize that 150 is really 5 30s. And if you know that 30 is pi over 6, this is just 5 pi over 6s, okay? Things like 315 degrees. If you know that this is really 7 45s, okay, that's very easy to convert it, okay, to just 7 pi over 4. All right. Now, if you have something like 22 degrees, right, well, that's not a nice multiple of 30 or 45. So then you would have to run it through that formula. All right, so something like 22 degrees, well, you'd have to multiply it by pi over 180. All right, and you could only go so far with it. This would become 11 pi over 90. That can't be reduced anymore. Okay, now it could be turned into a decimal. All of these radian measures are in terms of pi, but understand that radians can be expressed as a decimal as well as exact value with a pi in it. Okay, if you see a question that says to express something in its exact value form, or just exact value in general, that's where you want to have a pi in it. Okay, but understand that these are actual numbers, right? Pi is about 3.14, so all of these could be converted to decimals. Okay, and it goes the other way too. Suppose you have 3 radians, and we want to figure out how many degrees is this, okay? Well, you would just do 3 times 180 over pi, and you would do that using your calculator. You get 171.8, so 172 degrees. This would be approximately if you were to round. So in this situation, 3 radians, all right, that is an actual number, right? You're used to seeing radians with a pi in it, okay? But you're not always going to see radians with a pi. Sometimes you're just going to have a number like 3, okay? And this should make sense to you since pi is about 3.14. Pi radians, we said, is 180. 3 radians is a little less than that, so it should make sense that it's 172.